This is a mini lesson on conditional probability and how we might solve problems with probability distribution tables when there's a conditional probability being asked for. Now, I want to remind you that conditional probability is effectively a set restriction. So if we say the probability of rolling a 6 on a six-sided die, given that the number is even, we go from 6 options to 3 options. So we restrict the set. And in a probability distribution, it's kind of the same idea. We're restricting the distribution. Now, I've got here exercise 13C, questions 6, 8, and 9. These are problems for you to try after I've gone through the theory, if you want to. I'm making it optional. If you have a look at it at least and go, oh, this is fine, then you don't need to do anything further. Okay, let's get stuck into it. I've got an example here. And in this example, we've got some variables, 0, 1, 2, and 3, and some probabilities here. So this is our classic probability distribution. And the question is, what's the probability of the score, or x, being greater than or equal to 3, given x is greater than or equal to 2? Now, without this bit here, remember that's the given symbol. Without this bit here, it'd be what's the probability of x greater than or equal to 3? And you'd look at the table and you'd say, well, the only value that's greater than or equal to 3 is 3, and so the probability would be 0.4. Done, done, done. But how would you do it with a given statement? Okay. So I'll zoom out, but ignore the top left because that's for a different video. So what we do is we work out the probability of x greater than or equal to 2. And we can see that the probability of x greater than or equal to 2 is going to be 0.1, that's the probability of x equal to 2, plus 0.4, that's the probability of x equal to 3. So we end up with a probability of 0.5, like so. Then we work out the probability of x greater than or equal to 3, and that is just 0.4. It's the same as the probability of x equal to 3. So therefore, the probability that x is greater than or equal to 3, given that x is greater than or equal to 2, is where we bring our set restriction in. So we're going to say the probability of x greater than or equal to 3 is 0.4, out of a possible 0.5 of the probability distribution. Then you can pop that into your calculator if you want to, or you can work it out by going, that's 4/5, however it works for you. That gives you a final probability of 0.8. And that kind of feels right, doesn't it? If we know that the probability is in this area here, and it's 0.4 for just this bit here, it kind of makes sense that it would be a fairly high probability that's going to be a 3. It ends up being 0.8. That's it. So if you want to have a go at doing exercise 13C, questions 6, 8, and 9, please feel free to do so. At least have a look at them and make sure that the kinds of questions being asked here are ones that you could answer. But if you're happy with it, there's no need to do anything further.